welcome to this Misostudy video class, and as it is very much clear to all of you just by watching this first slide that we are in a phase of discussing problems from electromagnetic induction, and that too JEE advanced pattern exercise. Now if you try to recall, just some time back we presented a small shoot, you can say, with the help of 5 questions. So as per my promise, again I am back with more good questions. Now students, here I would like to mention a very important fact. What is that? You know that in JEE advanced pattern there are around 5 or 6 types of questions they love to ask, means IIT professors. What are those questions? One is, you can say, where only one option is correct. Fine. So that was our main focus in our first video of this topic. Then another is like more than one option may be correct. Then passage based question. Passage based means a small paragraph is given, then 2 or 3 questions based upon those paragraph, that paragraph. Another is matrix match. Then you can say integer type question, and then you can say analytical or descriptive questions. So basically they want to check your preparation by means of various questions. So I thought it's better to incorporate that change also in our video so that you can equip yourself in a much better fashion. Okay. So as we completed some simple questions in our first video, here I am going to use some other pattern of questions also, so that you can get the real exposure, real feel of this advanced pattern exam. So let's start our discussion with the question number 6, because I think in that particular shoot there were 5, so I thought it's better to start with a new sequence. Okay. So here is this question, obviously next to next to next and so on, but here you have to read and understand this paragraph first. After that, one by one I'll pick up questions and will try to find out the solution. My request to all of you is, because of some technical issues, it's not possible for me to show this entire paragraph every time. So initially I will elaborate this entire paragraph, try to understand. Then one by one I will show you the question in this fashion. Say for example, this question based upon that paragraph, this question and so on. Fine. So passage based question, and I picked 3 questions based upon this paragraph, that is question number 6, 7 and 8. So for the time being, please don't allow any other thought in your mind. Okay, just try to put this entire explanation in your mind so that when I am coming on to the questions, it's going to be easier for you to grasp or to understand. Here is the question, paragraph. Basically, one is source. First let me explain you the diagram. Then there is a capacitor, a resistor and a inductor or a coil. 2 switches, S1 and S2. What is mentioned over here, for the time being I have nothing to do with that. Let's try to understand from this diagram. If I put S1 close means right now S1 is in this fashion. If I put it like this, then this first half will start conducting fine current. If I remove it again and then S2 I'll put it like this, so what will happen? Due to the charging of this capacitor, flow of energy will start in this coil. And if I close both, situation will be different. Fine. So basically there are 3 possibilities, and you can say on the basis of that these 3 type of questions 6, 7, 8 I picked. Okay. Now come on to the paragraph. The capacitor of capacitance C, fine, can be changed, it can vary with the help of a resistance R, fine, by a voltage source V by closing switch S1, close it the way I explained, while keeping switch S2 open. That is situation number 1. The capacitor can be connected in series with an inductor by closing S2 and opening S1. So, it is your choice, close, open, close, open. Now, please take a look of this diagram, this circuit for few seconds. Close your eyes, put it in your mind, because now I am moving on to the first question based upon this paragraph. Okay? If required during the explanation, I will again show the paragraph. Don't worry on that part. So, here comes the question. Let us try to understand what exactly has been asked. Fine. Initially, the capacitor was uncharged. So, close your eyes, listen my words. Initially, the capacitor was uncharged. Fine, no problem. Now, switch S1 is closed, at least 3 or 4 times I am repeating this, and S2 is kept open. So, flow of energy, current, is because of the battery B source. If time constant of this circuit is tau, fine, time constant is tau, time is t, then out of these 4 options, which one is correct? Now, right now, no need of read these options. What we will do? We will do whatever we are supposed to do on the basis of this instruction. Then we will read our options and will find out which one is correct. Fine. As you know, no space is available over here. So, what I will do? I will turn and use this space to show you what exactly is required for understanding, and in this process, if some portion of the question is hidden, I hope you will not mind that. Now, what exactly the process? At any time, one thing you can say about this problem, and this is the beauty of JEE advanced pattern question. Not even a single question with, or you can say from a single approach. No. Here capacitor is connected. So, whatever you learned in chapter 2, that you have to apply. Then inductor is connected, okay, and then source and resistance is also connected. So, you can say at least 4 different concepts. I mean, they are correlated, but 4 different type of concepts are applied over here. So, at any time t, fine, change of charge on the capacitor. Why I am saying this? Because initially the capacitor is uncharged. When you close switch S1, close your eyes, think about S1, then energy will start flow. So, at any time t, charge on C, rather than writing capacitor, I am simply writing C. At any time t, charge on C is Q is equal to Q naught 1 minus e to the power t by tau. Now, try to recall, during the discussion of second chapter, I explained this topic with the subtopic name charging, discharging of capacitor. Fine. So, direct relation used over here. Q is equal to Q naught 1 minus e to the power minus t by tau. Here, I should not write it, but few of you may feel some difficulty, that is why I am writing. Here, Q naught is equal to CV and T is equal to 2 tau. Fine. Now, few of you may say how I am writing 2 tau. Wait for that. I will explain you why. So, Q is equal to Q naught 1 minus e to the power minus t by tau. Now, Q naught is CV and t is equal to 2 tau. So what you have to do? You just replace this q naught by Cv and t by 2t. So rather than writing a new equation, what I will do, I will use a different color chalk to replace these values. Okay. So here it is Cv from this and it is 2 tau from here. Okay. Now this tau white and this tau blue, they are same. Here I am just using different colors so that you can understand. Cancel them. So now what exactly you will get? You will get q is equal to this blue Cv within bracket 1 minus e to the power minus 2. Fine. So let me write down now. It means finally what I can write down? I can write down q is equal to Cv, okay, within bracket 1 minus e to the power minus 2. Fine. Now let's try to analyze options also. Now I will show you why I used t is equal to 2 tau. Ultimately this is our relation. Let's start analyzing. After time interval tau, charge on capacitor is Cv by 2. No, charge on capacitor is Cv, obviously varying exponentially, but Cv. After time interval 2 tau, charge on the capacitor is Cv within bracket 1 minus e to the power minus 2. Now you can say, sir, you are very clever. You solved the problem and that's why putting 2t. Now I can waste your time. I can put tau, then 2 tau, then this value and then this value. But that is mere wastage of time. If you wish, you can put it like that. Fine. So from here you can say easily that this B is the correct option. But let me check this C and D also for you. The work done by the voltage source will be half of the heat dissipated when the capacitor is fully charged. For that you have to use the formula H is equal to I square RT type of result. That is not provided over here. So this is not for our purpose. Come over here. After time interval 2 tau, charge on capacitor is minus 1. No, we checked ourselves. It is minus 2. So you can say the question is simple, but what is the most difficult part of these type of questions? Yes, that is the beauty of this exam. Suppose in examination hall you are solving. Here I am providing you support. But if you are solving this problem in examination hall, checking this, checking this, checking this, checking this, really cumbersome. So what should be the approach? Yes, here some sort of intelligent approach is required. What is that? Now after reading this statement at the rough page that is provided, you should start quickly putting the values. Fine. And then easily you can find out the solution. So this was question number 6 based upon that paragraph. Next question that I will show you also based upon same paragraph. But before that, let me allow to clean up this green board for your new question. Now here comes next question. I hope still this diagram is fresh in your mind. Fine, take a look again this diagram. Now I am coming on to the question number 7. After the capacitor gets fully charged, if you just close your eyes and listen my words, everything is going to be crystal clear in front of your closed eyes. After the capacitor gets fully charged, S1 is opened and S2 is closed. So what will happen? Now capacitor will start providing energy to inductor. So closed so that the inductor is connected in series with the capacitor. Fine. Then what will happen? Once again, 4 options. To explain some intelligent approach, quick tricks, and to save your time, I'll again do what? First, I will solve the situation as per these instructions. Only then, one by one, I will start checking the options. Fine. Now, one thing is quite clear, that the capacitor fully charged means what? Now CV completed. And when S2 is closed, then energy flow will start from inductor. Okay. So we have to talk in terms of this energy concept, and that too conservation. Okay. It means what? Ideal assumption. No loss in wires. So what I can write down? I can write down half Li square, simple, energy stored in inductor, is equal to half CV square. You can say yes, we learned this relation in chapter number 2. We learned this relation in this chapter number 6, that is electromagnetic induction. And what a beautiful combination. You are combining from 2 and 4 together. Yes, because the components are present over there. Fine. Now, this and this, nothing to do. Okay. So, Li square, maximum value possible. CV square. Why I am writing maximum? Reason is, this person is not independent. Means, whatever the food, the energy it will provide, that is going to be maximum for this. Now, from here, let's try to analyze the options. Okay. So, first, at t is equal to 0, energy stored in the circuit is purely in the form of magnetic energy. No. Because at t is equal to 0, the capacitor will start providing to the inductor. So, at that point of time, how you can say magnetic total? Not possible. Come on to this B. At any time t is greater than 0, any time current in the circuit is in the same direction. That is also not true. Why? Reason is simple, because capacitor is now providing the energy. At t is greater than 0, there is no exchange of energy between the inductor and capacitor. No. Why? Because now, let's say at 10 am, let's say at 10 am we started this experiment and capacitor started providing the energy. So, at 10.1.1 means 10 hours, 1 minute, 1 second, obviously some exchange is taking place. So, this is also not true. Now, from here, at time t is greater than 0, maximum instantaneous current in the circuit is V under root C by L. Let's check it. So, I max is equal to V, very good, C, L. Correct. Simple explanation based upon what? Energy conservation concept. Fine. Remaining all other options, I explained why they are not correct. So, before moving to the next problem, let's try to clean up this green board for your new question. And this new question is also based upon the same paragraph. So, before moving on to the next problem, once again take a look. Keep it in your mind, fix it again, once again. Fine. And then this is your question. If the total charge stored in LC circuit, don't worry, I'll again show you, is Q naught, then for t is equal to 0 or greater than 0, which option is correct? Fine. I don't know which option is correct. Why to bother for that? Let's start from here. Total charge stored in LC circuit. Let's go back. let's go back to this situation. Now, actually LC circuit means this portion. It will start providing energy, energy will start flowing over here. Then again, because this S1 is open, so what will happen? Entire energy from here, again C will again provide to this inductor. So they will start playing a game of brotherhood. You take, give me back. You give, take me back. Something like that. So it's like that oscillations. So if I am saying LC circuit, fine, as SHM, simple harmonic motion in terms of energy exchange. So with this idea, where I am comparing this LC circuit with simple harmonic motion concepts, then we will try to find out the solution of question number 8 based upon this paragraph, this situation. Okay, so let's try to find out the entire solution. Once again I don't have any option, but comparing LC oscillations with SHM, ideal SHM, fine, SHM. Comparing LC oscillations with ideal SHM, what we can write down? And direct relation I am writing down. I will show you the related relation also, don't worry. d2q upon dt square is equal to minus omega square q. Fine, don't feel anything wrong. Why? Because now I am going to comparable equation, and that way you can say, oh, that is so beautiful correlated with this relation. That's the point. So d2q upon dt square is equal to minus omega square into q, where omega square is equal to 1 upon LC. Still I am sure few of you may looking this relation with some bubbling eyes. Okay, so for all of you, I think I should use this space just to correlate. Try to recall the situation. F is equal to minus kx, class 11th. MA is equal to minus kx, d2x upon dt square is equal to minus k by m into x. Oh, so now if I am writing, you will say yes, it is a standard equation. So the same thing I am doing over here, nothing else. Fine. So now omega square is equal to 1 upon LC. So what I can say? I can say Q is equal to minus LC d2q upon dt square. So let's erase this portion and write down this term. What is this term? That term is this Q is equal to, now transfer these terms over here. So what you can write down? You can write down minus LC d2q upon dt square. Fine. Now let's try to compare. So the charge Q itself saying on the capacitor. See the beauty of this question. A very simple fact from class 11th, and it is used in this chapter of class 12th in such a beautiful manner. That's why whenever I am explaining theoretical topics, I always used to suggest and request, don't read in physics any topic in isolation, because they all are correlated. If the class 11th concepts which I mentioned with this yellow color over here, just for your understanding, you can easily find out the solution of this particular problem. So now let's move ahead and we'll try to discuss another problem. Fine. So now this was a different approach from our side, where we tried to explain questions exactly based upon the phenomena, pattern asked in JEE Advanced exam. Fine. Yes, some sort of practice is required over here, obviously. So now let's come on to the question number 9. And in this particular question, once again, as I mentioned that there are 5-6 type of questions asked. So one is integer type. Now, what is the beauty of these questions? Integer type questions means, students, a question is given, no options. Fine. You have to solve the question. Correct answer will be a number from 0, 1, 2, 3 till 9. If your answer is coming like 12, incorrect. Correct answer between 0 to 9 only. Okay. So that's why I am picking these questions 9 and 10, integer type. Any pure number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the correct answer. Now, the most complicated part of these questions are I am saying, because there are 3-4 difficult things. Let's say, for example, you don't have the clarity of the concept used in the problem. You can't solve it, you can't get the correct answer. So don't waste your time. First thing, these are the difficulties. Second, if your calculation is not good, you are going to suffer. This time, because JEE Advanced exam is now totally computer based, CBT based. So as per the latest information, they will provide you a virtual calculator on the screen itself. So that way they are trying to make the calculation slightly easier for you. So you can relax for that front only. Fine. And then if you are not comfortable with the formula, then again a problem. So basically 3 things are required. One thing they solved, the calculation problem, but concept, and third aspect is formula and this putting these values together. That is something that you have to make yourself strong. So with this simple suggestion, let's start this question. And as such, no option is given, so you have to solve this question from initial. A series RC combination. Imagine the situation. RC means resistor and capacitor. Okay. So who is creating problem for me? This R and this C. Okay, no problem. Series means back to back they are connected to an AC voltage of angular frequency omega. So like 1 and 1, and then they are connected with the AC frequency. AC frequency means symbol is like this. I am providing you all components. Fine. I am not putting together. I am not preparing the food. I am giving you just contents, spices, oils, everything. If the impedance of the RC circuit, okay, Z. If the impedance of the RC circuit is this much given, the time constant in millisecond of the circuit is how much? Now, if I don't able to recall the time constant formula for this entire combination, I will not able to cook this product, will not able to enjoy. So ultimately, what I initially suggested, that is required over here. Fine. And then what I will do, I will start putting these components together. So let them remain over there. I will use this space. Now first formula is Z is equal to under root R square plus XC square. Even if, I am sorry to say, even if few of you are facing any difficulty over here, please revise. What is the exact formula for RLC? That is Z is equal to under root R square plus within bracket XL difference XC whole square. As such, no inductor, so simply XC. XC is what? XC is 1 upon omega C. XL is what? Omega into L. Whenever you solve the problems in this fashion, definitely in one problem you will revise and learn 3-4 correlated topics, concepts. Fine. So Z is equal to under root R square plus XC square. But in the problem, it is given that Z itself is equal to R under root 1.25. Okay. So at the place of this Z, I can put this R value. So I can say R square 1.25 is equal to R square plus XC square. What I did? Put the value both side square. Simple. Now 1.25 R square minus R square is equal to XC. Fine. So easily we can find the value of XC, that is 1.25 R square minus, transfer this R over here, R square is equal to XC square. I hope everyone is going to be comfortable with this. Now from here what we can write down? We can write down 0.25 R square is equal to XC square. I can do one thing. After this step, I can simply write down by putting the values and solving, and I can directly put the result. But what I mentioned in the starting, integer type question, even a small amount of mistake in calculation will definitely is something which is not advisable. So that's why I'm writing step by step, no scope for any error. Next step is what? Next step is R square, fine, upon, if you just solve it, you will get 100 upon this 25, fine, upon 100. So you will get it what? That I am directly writing, that is 25 R square upon 100. Remove this decimal place, XC square. 25 4 ja. So here I can very easily write down what? That is going to be XC is equal to R by 2. Okay. I remove this square. So XC is equal to R by 2. So now see how easily you can find the value of this XC. What is XC? XC is capacitive reactance of the circuit. Fine. Z value I have, R itself we know, and this XC now we calculated over here. Now from this yellow expression, if I am writing a simple term over here, that is 1 upon omega C is equal to R by 2. You will say no problem, this is just the decoding of this term. If it is XL, it is omega into L, fine. So now from here what I can mention, that tau is equal to CR is equal to 2 by omega, basic formula, fine. And in this formula, what is the value of omega given in the problem? 500 radian. So put the value. So that is tau is equal to 2 by 500, that is 1 by 250. Fine. And when you solve this 250, then tau is equal to 4 millisecond. So now what I initially suggested, 0, 1, 2, 3, 4, something like that. So integer is 4 is the correct answer. Fine. Now if in this particular problem, let's say just because of a mistake, I committed a blunder, I committed a small mistake, I will not get this answer. So say for example, I received the answer 3 or 5, meaningless, fine. That's why have patience in examination room. Don't rush, wait and then solve and get the correct answer. So, this question was not a difficult one, but yes, some sort of understanding and you can say some sort of careful approach is required. Okay. Let us move for the next question, as our this green board is clean and ready to serve us. Fine. So, here is your question number 10. Again, not a difficult question, but in the same category, integer type. Fine. My suggestion is, definitely in this problem I will follow the same approach. I mean, reading, understanding and then solving. If you wish, you can stop the video right now for 2-3 minutes. Read the question, try yourself. After that, run your video, match your solution. Choice is yours. Let us come on to the problem. A long circular tube of length L meter, that number is not important, and radius this much carries a current I along its curved surface as shown. This is current and this is a long tube. You can imagine this long tube as a solenoid. Fine. A wire loop of resistance 0.005 ohm and of radius r is placed inside this tube, this small wire, okay, with its axis coincide with the axis of the tube. Actually, I created this diagram keeping in mind that the diagram should be simple enough to get you the clarity. Okay. I hope that 3-dimensional aspect is clear. The current varies as I is equal to I naught cos omega t, sinusoidal, where I naught is constant, peak value of current. If the magnetic moment of the loop is n times mu naught I naught sin 300 t, then what is the value of n? Your target is hidden at this corner, and this is creating a problem for you. So, first you have to find out what we have to achieve. Oh, that is small person. So, first this capital N. Now, he is going to be our target, we will try to hit it. Let us utilize this. B is equal to mu naught N I. Why I am writing like this? Who gave me the right? Oh, I simply mentioned, imagine this tube as a solenoid. So, now I can write down like this, where small n is capital N upon small n, number of turns per unit length. Fine. Whenever you are writing the formula like this while in your home or school while practicing, don't keep on writing. Write the formula. Think on the terms. Okay, what is the meaning of N? Fine. What is the meaning of B? So that you can keep revising all associated aspects also. Now, B is equal to mu naught I, but N I, this term itself is equal to what? I by L, that is total current in total length. Replace it. So, very easily I can write down mu naught I by L. No problem, simple replacement. Fine. So, now B is equal to mu naught I L. So, flux, fine, flux through this circular turn. So, flux through every line I am writing so that you can understand. So, flux through the circular wire, flux through the circular wire, or let us say circular coil. I think that is better term. So, flux through the circular coil is, let us use blue chalk, phi is equal to B S, S is area. What is the value of B? The value of B is this. And what is the value of this small s? Pi r square, simple. Fine, circular area. So, let me allow to write down this value of phi as phi is equal to mu naught I by L into pi r square. No problem, simple terms, fine. Now, what is the induced EMF? Starting of first question of one of the previous video, I mentioned that induced EMF is minus d phi b by dt. Keep writing these formulae again and again. The more you will do the practice, the more perfection you will achieve. Okay. So, using this relation, fine, over here using this relation, what I can say, induced EMF, induced EMF, fine. From this relation we can find out. So, now I am not writing the expression, but I am directly writing the current relation. So, induced EMF, this implies that, I hope the sentence is clear, I induced, it means because of this induced EMF, whatever the current is induced, that I am going to write down. So, it is minus, and of course the value of B, that is mu naught within bracket mu naught upon L into pi r square upon r, fine, and that is di by dt, yes. Simply putting the values, nothing else we are going to do over here, that is R. Fine. Now, this is the value of the induced current. What is the value of you can say a magnetic moment? So, magnetic moment is nothing but NIA. What is the value of N? 1 coil, 1 turn, so 1. Therefore, it is IA, and which I? This induced I. So, I into A. Now, put the value of I and also put the value of pi r square, this term, fine. So, by putting the values, now here I am not writing each and every step because this is a trivial part, simple, you have to just put the values. By putting the values and solving, N is nearly equal to 6, because in previous problem I solved each and every step. So, I thought here I should give you some amount of homework where you can work upon yourself and you can get the value of N as 6. Fine. Again an integer in the category of 0, 1, 2, 3, 4, 5, 6 till 9, any number. Now, in these type of questions, there is no negative marking. Fine. Because they know either you can solve it or you can't solve it. So, there is no scope for negative marking. But if you make yourself comfortable with the basics, these questions are very simple. Analyze both the questions, no new formula, no difficult aspect, simple relations and explanations, fine. Now students, I would like to say once again that yes, these 5 questions slightly long, some different approach, and in coming videos definitely we will pick up more different type of questions, maybe fill in the blanks, maybe analytical type, maybe matrix math type. Don't worry for that, you just keep on enjoying, keep on revising. So finally I would like to say, keep revising, keep enjoying, be the part of these sessions, make your preparation perfect with the help of Misostudy. So thanks a lot for watching this video. Once again, thanks.